minus 2 equals 10. We're going to solve a two-step equation. First, let us show it using manipulatives. So this is a balance scale. What we do on the left, we do on the right. So let us represent the 4x. X is represented by 4 squares. Each of these squares represents a value which we don't know. And then minus 2, to show minus 2, instead of using my yellow chips, I use the red chips. So a negative 1 and a negative 1, that negative 2 represents this. So this left side is equal to the other side, which is 10 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this represents 4x minus 2 equals 10. It is a balance. Now, our objective is to remove some of the chips so that x will be alone. First, to remove a negative, I should throw 2 positives because a positive 1 plus a negative 1 becomes a 0. I throw this here, I throw this there, that becomes a 0. But remember, whatever I do on the left, I also do on the right. Since I threw 2 yellows here, I have to throw 2 yellows here. Now, what remains is that 4x is equal to 3, 6, 9, 12. If 4x's is equal to 12, what could be the value of a single x? We could see some matching here. That's easy because 4 divided by 4 gives me an x. And 12 divided by 4 equals 3. So I could say that 1x is equal to 3. Let's check. Is 1x really equal to 3? Let's bring back our original data. So, here we go. So we said 1 single x is actually equal to 3. So I put in that 3. I put in that 3. I put in another set of 3 to replace that x, and another set of 3. So let's get rid of those x's because each of those x's has a value of 3. Now we could see here that this left side should be equal to the right side. When you see a positive and negative, that adds up and becomes a 0. Let's take that out. A positive and negative, take that out. So let's check, will it be a balanced equation? On the left side, I got 10. On the right side, I got 10. So I'm right. X is equal to 3. Now we will represent 4x minus 2 equals 10 into a model, words, and symbols. Remember what we did? When we use the manipulatives, we will now translate this into a model. So we started with 4x's on the left and 2 negatives on the left side. On the other side, I have 10. To get rid of the negative, I threw 1 positive and 1 positive. It canceled out. So let me throw 2 again on the other side. So what remains now is 4x's. And on the other side, this will now show 12 singles. I want to know the value of 1x. So to know the value of 1x, I could see that I could split this into 4. On the other side, I could split into 4. So each of the x would actually have a value of 3. So on the left side, I could say now that x is equal to 3. In words, we said 4 x's and 2 negative singles is equal to 10 singles. To get rid of the negative, what we do? We added 2 positives. Therefore, on the other side, I add 2 positives. And then, when we did that, what remains? This cancels out because 2 positive and 2 negatives become 0. So what remains are 4 x's is equal to the 10, and the 2 becomes 12 singles. The next thing we did was to divide that by 4, divided by 4, divide by 4, divide by 4. We got finally our x to be alone, which is equal to 3. Now, to write that as symbols, or sometimes they say algebraically, you write 4x minus 2 equals 10. Remember, we added 2 on the left, we added 2 on the right. Remember to keep the balance. Whatever you do on the left, you have to do on the right. That canceled out, and now we have 4x alone is equal to 12 singles, which is the number 12. To get the value of x, the opposite of multiplying, what we did was to divide by 4 on the left, divide by 4 on the right. Therefore, x is equal to 12 divided by 4. It's a 3.